Hello, my name is Roland Bell, and for my final project in data mining, I decided to create a movie plot-based IMDb score estimator. So the goal of this project was to create a tool that takes some arbitrary movie plot summary as your input and outputs a predicted IMDb score. Now, can this even work? That's kind of the big question of this project. My dataset was found on Kaggle, of course. It is a huge resource for this sort of thing, and I was luckily able to find a dataset with everything I needed, though it was quite difficult initially because there were not many datasets that fit my exact specifications of having these certain features. I ended up using the TMDB 5000 movie dataset, which has metadata on around 5,000 movies from TMDB, which is a way to get around the DMCA issues with using IMDb, but has pretty close to the same information. Most importantly with this was the fact that it had a title, plot summary, of course, and then an average of view scores and the number of votes received, which is important for determining our metric. The methodology of this is we base it off of what IMDb sort of uses internally to rank movies. We give each movie an aggregated review score, and we turn those into a weighted rank. So breaking that down, we take our votes, that's V here, that a movie received, and we take our minimum votes that we find, which is we use essentially the 90th quartile for the actual amount of votes something receives in order to sort of exclude movies that we don't think have enough votes to be viable and to bring other movies down to size. We also use an average rating that we determine from all of our movies and a mean vote amount for a particular movie across our entire data set. So that's how we actually did it methodology-wise. We used a k nearest neighbor sort of setup with the TF-IDF vectors based on the plot descriptions, and then we ran our tests. We created an estimator that would allow you to plug in a plot, and it would output, of course, that score that it absolutely deserves on IMDb. We needed to determine the most effective k-value using cross-validation and then use that k-value to make an effective estimator. Next step, maybe profit? Ooh. So what were our initial results? We initially got this strange shape in our results, which we were at first at a loss to figure out what was going on here. And by we, I mean me, of course. I keep using the whole data science we here. But this is based on actually how I process the data. And I realized this is an error on my part. So what happened is you can see that on the tail ends of this, the error is way worse than the 0.5, which isn't even particularly good for a 1 to 10 estimate score here. But I found that the middle of the data actually had this way better performance, and I had realized that when I was initially testing to see whether my score system worked, the IMDb score that I generated, I sorted the whole data set and I took the top ones to see if they compared with IMDb's top movies or whatever. And so because I had been splitting k-fold without randomization, I ended up just finding that the average movies had pretty close to average scores, which my thing was good at averaging. So this was ultimately not indicative of the actual patterns represented in the data, but I wanted to include this as an example of where I made a mistake. So our true results look more like this. This isn't looking too good for our hypothesis right now, and as you can see, it doesn't matter what your k is, the max error is going to vary wildly, somewhere between around 1-ish to almost 2-ish. And this sort of I ran this a few times with different random k-fold things, and it didn't get much better. It was sort of just a scramble, and all that a higher k value did was just bring it closer to an average score, which of course made it slightly better with error. I wanted to try and see if you could clean up that messy graph earlier by making a sort of results thing here where I average the error. And while you can see the data better, it definitely doesn't show any good signs for us here. Most of our average max error is in this range of 1.15 to 1.5, which is absolutely insane. Guessing an IMDb score with a plus or minus of 1 at all is just absolutely absurd. So this kind of leads us to our conclusion, which just kind of shows it doesn't really work. We do not necessarily reject our hypothesis, but we can't support it given this data. There is probably no relationship directly between a movie's plot, summary, and the IMDb score. You could take this a step further and use larger plot summaries, and maybe the few sentence ones I had didn't have enough data. But ultimately, this kind of proves a relationship that we expected was there. But anyways, thank you for listening to me, and thank you for checking this out. I hope you thought this was at least very interesting. And Professor, thank you for a good year.